This is 2019 AP Physics 2 FRQ. The two circuits shown above contain an ideal variable power supply, an ohmic resistor of resistance R, an ammeter A, and two voltmeters VPS and VR. In circuit 1, the ammeter has negligible resistance, and in circuit 2, the ammeter has significant internal ohmic resistance R. The potential difference of the power supply is varied, and measurements of current and potential difference are recorded. The axis below can be used to graph the current measured by the ammeter as a function of the potential difference measured across the power supply. On the axis, do the following. Sketch a possible graph for circuit 1 and label it 1. Sketch a possible graph for circuit 2 and label it 2. B bit. Let delta VPS be the potential difference measured by voltmeter VPS across the power supply, and let I be the current measured by the ammeter A. For each circuit, write an equation that satisfies conservation of energy in terms of delta VPS, I, R, and internal resistance R as appropriate. Explain how your equations in part B account for any differences between graphs 1 and 2 in part A. D. In circuit 2, R is equal to 40 ohm and voltmeter BPS reads 3 volts, voltmeter VR reads 2.5 volts. Calculate the internal resistance R of the ammeter. Next, voltmeter VR in circuit 2 is replaced by a resistor with resistance 120 ohms to create circuit 3 shown below. Voltmeter VPS still reads 3 volts. Calculate the equivalent resistance Req of the circuit. Calculate the current in each of the resistors that are in parallel. That's it. Now, what I do is I will start answering the second question first, B bit first, and then go for the A bit, so that I have an idea of the graph, how the graph should be. Okay. Otherwise, drawing the graph is a bit perplexing. Okay. See here, these two circuits are almost same. Only difference is the second circuit has an internal resistance of R for the ammeter. But in the first circuit, the ammeter has a negligible internal resistance. That's it. So using the Ohm's law, we have the Ohm's law now. Ohm's law equation. This question is based on Ohm's law, basically. Okay. First, that you should realize. Ohm's law states that the voltage across the load is proportional to the current flowing across the ends of the resistor or conductor, provided all the physical parameters remain constant. That means the temperature should be constant. So V is proportional to I, directly proportional to I. As the current increases, voltage increases, or as the voltage increases, current increases. Okay. The same thing I represented here. V is proportional to I, or V is equal to IR. Therefore, R is equal to V by I. Am I right? So the graph, if we plot a graph of voltage versus current graph, the graph will be like this. It follows the equation y is equal to mx plus c, and then the graph will be like this. And then the slope of the graph gives the resistance. Okay. But here, he is asking us to draw a graph between current versus potential difference. Okay. So that thing we should keep in mind. Now, let me write the equations for the circuit 1 and circuit 2 based on the Ohm's law. So, according to Ohm's law, V is equal to IR. No, therefore, the voltage across the power supply must be equal to current flowing through the circuit times the resistance of the circuit. So, for the first circuit, we have only R is the resistance. Am I right? No other resistance is there because the ammeter has negligible resistance. Therefore, delta VPS, I wrote here, delta VPS is equal to IR, or R is equal to delta VPS by I. Given the symbols, what are the symbols he gave? I used those appropriate symbols and then I wrote the equation. Same lines, V is equal to IR lines. Now coming to the second circuit. Second circuit, the effective resistance is R plus R. Ammeter and the resistor are in series. Therefore, the total effective resistance is R plus R. So the voltage across the power supply must be equal to the current flowing in the circuit times the effective resistance. So delta VPS is equal to I times R plus R, or R plus R is equal to delta VPS by I. Okay. And from these two equations, you can make out that the second circuit has a higher resistance. Okay. So higher resistance means the slope must be less. Am I right? Here, the slope gives the, because current versus potential difference, the graph we are drawing. So here, current versus current by the slope gives, we have to take the slope, no, to find out the resistance, we have to take the slope. Here, the slope gives, instead of R, 1 by R it gives. Okay. So here, we take the 1 by R, 1 by R is equal to slope. R, we can write R is equal to 1 by slope. Okay. So here R is more means if you see the circuits or the equations, the resistance for the second circuit is more. That means the slope must be less. See here. Slope is equal to 1 by R. If R denominator is more means the value of the fraction will be less. Am I right? Therefore, here R is more. The resistance of the second circuit is more compared to the first circuit. Therefore, the slope must be less. So, the line will be like this. This is the line we are drawing for the second circuit. And then this is the line drawing the graph for the first circuit. We labeled it. So, A bit and B bit we answered. And then in the C bit, he is asking us to explain. Explain your equations in part B, account for any differences between graphs 1 and 2 in part A. So we wrote the differences. Okay, the difference in the above equations is resistance, which we get from inverse of the slope. Higher the slope, lower the resistance, which is evident from the equations. Okay, so that is the answer for C bit. Now, D bit. What is the D bit in circuit 2? R is equal to 40 ohms. When voltmeter VPS reads 3 volts and voltmeter VR reads 2.5 volts, calculate the internal resistance of the ammeter. So for that, what we have to do is first we have to find out the voltage across we have to calculate the current flowing through the this one. Here, this is the circuit, no? Second circuit. From the second circuit only, we can calculate the R, okay, internal resistance. For that, what we do is we have the voltage and resistance. Am I right? So first, we let us find out the current flowing through the circuit. Okay. What is the current flowing in the circuit? R current flowing through the resistor R, main resistor. This is the load, no? R is the, this is the load. 40 ohms is the load. He gave the value for 40 ohms as the resistance here. So what is the current flowing here? Current flowing is equal to voltage divided by the resistance gives the current flowing through the resistor R. Okay. Now, according to the second equation, delta VPS is equal to I times R plus R. What is the voltage across the power supply? 3 volts. Okay. So this 3 volts is equal to the current flowing times the total resistance 40 plus R. Okay. We use this equation and then we will find out R. See here the calculation. I made the calculation. Initially, I calculated the current flowing through the resistor. Okay, that is this one. So using that one, I calculated the internal resistance. Agree? He gave the values. What is the voltage across the resistor? It is not same as the supply voltage. Okay, power supply has the 3 volts voltage, but here the voltage is different. That is why we have to calculate the current flowing through the resistor, and then finally we have to calculate the internal resistance. Okay. So the internal resistance is 8 ohms. Now, later what happens, he replaced the voltmeter here, this voltmeter with a 120 ohms resistor. This is the circuit. We have to find out the effective resistance of the circuit. So this is first, this is a parallel circuit. So for parallel circuit, we have to find out the effective resistance. So for that, this is effective resistance is 30 ohms. Here is the calculation. Okay, see the calculation. From this, we found out the effective resistance as 30 ohms. Okay, now this 30 ohms is in series with the ammeter. So what is the effective resistance of the circuit? 30 plus 8 is equal to 38 ohms is the effective resistance of the whole circuit. That is the answer for this one. Okay. Now we have to find out the current flowing through each resistor. So for that, what we do, we will calculate the current flowing in the circuit. Okay. What is the current flowing in the circuit? We know V is equal to IR or I is equal to V by R. So V is 3 volts. Here he gave 3 volts. VPS is equal to 3 volts. And then the effective resistance is 38 ohms. Therefore, the current flowing in the circuit is 0.08 amperes. Okay. And now we have to find out the current flowing through each resistor. For that, because these two resistors are in parallel with each other, the voltage or the potential drop across these resistors are same. Okay. So what we have to do, we have to find out the voltage drop at the junction. So voltage drop at the junction is equal to total voltage at the power supply minus voltage drop at the ammeter. Then that gives this one. So VPS minus voltage across this one is equal to voltage at the junction. Same thing I did. So VPS is equal to 3 minus voltage across the ammeter. Ammeter is equal to, ammeter has 8 ohms resistance. So resistance into current gives the voltage. Okay, V is equal to IR. That formula I used, and then I calculated the voltage across the ammeter as 0.631 volts. So subtracting this voltage from the supply voltage gives the voltage across the junction. Once we find out the voltage across the junction, we will calculate the resistance across each resistor. Okay, voltage divided by resistance gives the current. The same way I calculated the current flowing through each resistor. Okay, so this is 0.06 amperes and 0.02 amperes. I first noted down that actual value, and then I truncated the value R to the two significant figures. Okay, all the answers are to the two significant figures. Okay, so this is the answer for this question. Hope this helps. Thank you. This is just Ohm's law. That's all. Thank you. Bye bye.